Bismillahirrahmanirrahim. And Assalamualaikum warahmatullahi wabarakatuh, and very good morning to everybody. So for today, we will continue our chapter regarding the chapter 4, which is alkenes. So this is chapter 4 now. So we will have the remaining chapters is around 2 chapters soon. We try to finish as best as we can, okay, including discussing the questions that I already given to you. So alkenes, okay, it's sp3 hybridizations. All carbon is saturated. So regarding these chapters, we will cover introductions as usual, and cycloalkanes, nomenclature, how to name the compounds, and naming the cycloalkanes, of course, okay, common name for the alkenes, fossil fuels. It's kind of the source of most of the organic solvents. And physical properties, conformations of ethane, conformation of butane, and introduction of cycloalkanes, okay, cycloalkanes and substituted cycloalkanes, and oxidation of alkenes, including lipids. So the thing that I already highlighted in red, which is quite important, okay, and this chapter also we will learn how to name the compounds, how to draw the compounds, and how to do the Newmans and projections and shape projections also. So for the acyclic alkenes, which is non-cyclic alkenes, alkenes are aliphatic hydrocarbons, okay, having only CC and CH sigma bonds, okay, that can be categorized as acyclic or cyclic compounds. And acyclic have the molecular formula CnH2n+2, okay, where n can be any n integral. So they can contain linear or branch change, yeah, of course, okay, and we have to determine the name based on the long of carbon change. So for example, this is aldecanes. They have 11 carbons, okay, and they are also called saturated hydrocarbons because all carbons already occupied with hydrogens, okay, and that's why the formula molecule is CnH2n+2, okay. For the cycloalkane, it's the cyclic compounds that can be contain carbon joined in one or more rings, okay, because their general formula is CnH2n without +2 because n to n carbon have been connected. There are 2 fewer hydrogen carbon than acyclic alkenes. This is a very famous examples, cyclohexanes, CnH2n. So for tetrahedral and geometry of carbons, usually the cycloalkanes, the alkenes, okay, have already surrounded by 4 carbons and making them around sp3 hybridized, and the shape is a tetrahedrals. Okay, the angle bond is around 109.5. So this is kind of representations of this alkene. For example, we have methane here. The Lewis structure is kind of like this, okay, and 3D representation is like this. We will learn more about 3D representation in chapter 5 soon. And this is the shape of ball and stick models, and we will see clearly the angle is 109.5. Okay, and we have to, usually we are using skeletal structures. This is one to make sure you understand how the methane or alkene look like. So 3 carbons, which is propane here, have a molecular formula C3H8, okay, CnH2n+2, because this is the non-cyclic cyclic alkenes. So this is how you can draw the propane by using skeletal structure. Usually we are using skeletal structures. And this is the pentane. Also, you can draw like this for structure A. Okay, for the structure A like this. B, C, and D. So they have also 5 carbons here. So you have to refer C, H, 2. Okay. So yeah, variety way. You can draw the representation of pentane in a variety of ways. So for constitutional isomers, okay, there are 2 different ways how to use carbon, how you can draw the butanes. Okay, first we can name it butanes. The second one is isobutanes. This is what we call constitutional isomers, or in Malay we call isomer kedudukan. So okay, they have 2 ways to draw it. Okay, so this is the first one, A, with the long range straight change of alkanes. This is the branch, okay, of alkanes. If we call isopropane, isobutanes, you know how to do it, okay. Isopentane. Okay, you have to understand the definitions. Okay, constitutional isomers or structural isomers differ the way of atom are connected to each other. Okay. Okay, naming the alkenes, they are suffix A and E in the end, okay, because alkenes, A and E. So you have to remember this one doesn't have any choice. Okay, for example, octanes, nonananes. This one 1 to 7, 1 to 8 is okay, but 9 to 20 is difficult because you have to memorize this one. Okay. For example, 10 is decane. Okay, 11 is undecane, dodecane, tridecane is for 13s. Okay, for 20 is isocene. For the cycloalkanes, okay, cyclo, we know the word cyclo is mean the cyclic compounds. Okay, molecular formula is CnH2n. So this is kind of example of cycloalkanes. We have propane, we have cyclobutane, cyclopentane, and cyclohexanes, but we will study more about the cyclohexane soon. So be prepared because we will do more example about the cyclohexanes. Okay. So make sure if the compound is cyclic, you have to add the prefix is cyclo. Okay. So for the nomenclature, how you can name the compounds. So they have 3 parts. The parent names, okay. The parent names indicate the number of carbon is longest continuous change. Longest continuous change. Parent name, the main name, okay. So if you have 6, is become hexane. So the suffix, okay. Parents is the most important things. Okay, suffix indicate the functional group in presence. Okay, because for example, we have hex is 6, A and E is a functional groups. Present is alkanes, and prefix should be in the front. It tells us identity, locations, and number of substitutions. Okay, this is very important. If they have the branch structure, so you have to find the longest change first and name the branch based on numbers. Okay. So for the naming substitutions for the alkyl groups, okay, alkyl groups are performed to remove 1 H, yes, because for examples, methyl we have CH3, and you have H. This is methane. So we will call methyl because we have to move one H to make sure this carbon, this bond have been attached to the main skeletons. Okay. So to name the alkyl group, change the A and E ending to the parent alkene. So for example, methane is become methyl, ethane is become ethyl. Okay. Acyl, for example, for the 6 carbon as a branch. So this is kind of example. Methane is become methyl, ethane is become ethyl. Okay, naming 3 carbon alkyl groups. Okay, this is propyl. Okay, they have 2 types of propyls. Okay, if we remove the primary hydrogens here, it's become propyl. Okay, and if we from propane, okay, if this one is if this propane group is become prefix. Okay, is become prefix. So if okay, we will use prefix as propyl if this compound have been in the branch positions. Okay, if we remove the secondary, it's become isopropyl. The difference is this one connecting here, this one is connecting here. Okay, it's the most important thing. So if this one is 3 carbon, okay, 3 carbon. This one we have 4 carbons. Okay, 4 carbons we can call butanes. Okay, they have two different isomers. Okay, which in 4 possible alkyl group contain 4 carbons. First, if we remove in these positions, the proton in these positions, we make to the branch. Okay, and this is become butyl. Okay, if we remove in these positions, it's become secondary butyl because it's a secondary carbons. Okay, and meanwhile, if they have butyl, they still have butyl, but it's from butanes, it's become 2 methyl butane. It means we make another methyl groups as a branch. So if we remove 1 proton in these positions, it's become isobutyl, similar like isopropyls. Okay, and if we remove the tertiary proton in these positions, this is tertiary, this is a secondary, it will become third butyl. Okay. This one you have to what can say is make more exercise about this one. You cannot memorize easily about this one. Okay, how to name the alkane using the IUPAC system? This is the worldwide system that we use. That we use for the naming of compounds. So IUPAC systems, and I already put additional notes around 25 pages about how to name the compounds. Okay, you can read for that one also. Okay, first you have to find the longest continuous chain. Okay, continuous chain. This one is, and after that, put the suffix. In this case, is A and E. Okay, so we have to name the parent. Okay, parent. Okay, you remember we have prefix, parent, and suffix. So first, find the longest chain. In this one, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon is the longest chain. If we count from here, 1, 2, 3, 4, 5, 6, 7, it's 7. If we count from here, 1, 2, 3, 4, 5, 6, 7, it's 7. 1, 2, 3, 4, 5, 6, and 7. 7. 8 is the longest one. Okay. So first you have to count the longest carbon continuous chain. Okay. Doesn't matter if the chain is straight or bent, but make sure it's continuous. The keyword is continuous. If there are 2 chains equal length, if you there are two chains equal length, pick the chain with more substituents. So in this one, we have this one. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, but they have two substituents compared to this one. 1, 2, 3, 4, 5, 6, 7. It's better to have more substituents. Okay, this is the keywords, more substituents. So, okay. So number 2, what you have to do is number atom chain to give a first substituents the lowest number. So this is the example that we have before. So we have 8 carbons. So we have two possibilities to naming it here, from here, or from here. So you can do one by one. 1, 2, 3, 4, 5, 6, 7, 8. So the longest, the first substituent is carbon number 2. Okay. For meanwhile, this one the first substituent is carbon number 3. So this one is the correct one. Okay, if the first substituent are the same distance from the both end, okay, find the second substituents at the lower numbers. This is another examples. We have 6 carbon here. Both of that, we have two possibilities to numbering the substituent from this side and from this side. So if we start from here, the second one is a methyl, which is the second substituent, C2, and the second substituent is at carbon number 3. So meanwhile, if this one is carbon number 1, similar like these examples, so but the second substituent is carbon number 4. So this one is preferable to take it, okay, from starting from here is as a first carbon. Okay. And when numbering carbon change result in the same low numbers at the end of lowest number alphabetical the first substitutions. Okay, for example, this one we have 7 carbons. We can start from here and here. So they have two possibilities. We have number third substitutions. Okay, similar. We have third substitutions also. We have 5 and we have 5 also in these positions. But the difference is we have methyl and ethyl. Okay, so this one should be the correct arrangements because E alphabetical order, okay, A, B, C until Z. So this one is E and this one is M. Okay, so this is they are preferred to naming like this. Okay, so compared to this one because we should find E first followed by M. Okay, alphabetical order. Okay, where is alphabetical order? So the third one, name the number of and the substituents. Okay, name the substituent as alkyl groups. We have in this example we have 3 substitutions. So the first one is methyl, the second one is ethyl, and third one is methyl also. So we have the longest chain is carbon 8. Okay, 8 carbons. Okay. Every carbon belongs to either the longest chain or the substituents, not both. Either, okay, faham ni perkataan ni? Okay, so each substituents need their own numbers. Okay, we have numbering here, okay, by following the previous steps. So put number 1, 2, 3, 4, 5, 6, 7, 8. Okay, and you can for 2 more identical substitutions. Okay, in this example, we have 2 methyls. So we can use prefix like di for 2, tri for 3, tetra for 4. Okay, and so on. So in this case, we have dimethyls. Okay, we have dimethyls. So for the step 4, combine the substitution names plus numbers plus prefix plus suffix. It means this is the last one, so you have to combine everything. Okay. Prefix plus parent plus suffix. Okay. Okay. Ignore all prefix except iso alphabetize, okay, the names, susun number, okay, mengikut turutan huruf A, B, C, alphabet. Untuk for substitutions, ignore all prefix except iso. Okay, iso is I. So for this one, okay, the previous example, we have 2 methyl here. So we can call this one is 5 ethyls, okay, 5 ethyls, 2,6-dimethyl octanes, okay. Oct is carbon 8, this one is alkane groups. So you have to arrange the substitutions, okay. Okay, we have 2 dimethyls, first one, okay, ignore M, okay, for this one if 5 ethyl. So we can start to name it from 5 ethyl to dimethyl octane. Okay. Combine substitution name and number prefix. Again, similar steps. Okay, separate number by commas. This is very important. Separate number by commas. If they have 2, 6, for example, 2, 6, you have to separate by commas. And separate number from letter by using hyphens. Okay, in this case, we have 6 and D. You have to separate by hyphens. And the name of alkane is single words. Yes, no spacing after hyphen and comma. Yes, it's become one words. Okay. How to name the cycloalkane using the IUPAC system? So you using the same rules as the linear compounds, but you have to add between prefix and parents cyclo. Okay. So for examples, find the parent as cycloalkane. For this one is cyclohexanes, 6-member rings, but you have to build. Okay, this is the cyclo words, this is the parents, this one is parents, and this one is suffix. Okay. Okay, name the number of substitutions. No number is needed, indicate a single substitution. If there are single substitution, no need to put numbers, okay, because it's easy for us to put any places, right? You can put, for examples, for this one, you can easily put methyl in this position also, because they are single substitutions, okay. So this one is a third butyl cyclopentanes, and this is cyclohexanes, okay. For ring with more than one substitutions, begin numbering at one substitution and proceed around the ring to give the second substitutions the lowest numbers. Okay, for examples, we have 2 CH3 here for cyclohexanes, okay, and we have 2 possibilities. We can start for clockwise or anti-clockwise. For example, this one is clockwise, okay, and this one is anti-clockwise. Okay, so for this one, if we start anti-clockwise, it's become the second substitution is the highest number, which is number 5. And this one, if we are following the clockwise, it's become the highest number, which become number 3, if we follow the clockwise. So for this one, it's better to follow to give the second substitution is the lowest numbers, okay, lowest numbers, or you can say lowest priority also, okay. So with 2 substitution number of the ring to assign the lowest numbers, the substitution alphabetically arranged alphabetically, okay. So for example, like by using this as examples, okay, so we have 2 groups, one is ethyl, one is methyl. You have to arrange, okay, you have to arrange alphabetically, okay. For example, we have letter E here, this one is letter M. So if you start from here, it's similar numbering, but the problem is we have to arrange by alphabetical order, alphabetically, okay. So we have to change this one to number 1, okay, and we have to flow clockwise. We have to put the second substitution is the lowest numbers. So this we are prefer to naming the compound like this, compared to like this. Okay, so it's become 1 ethyl, 3 methyls. Okay, and you have to mention the positions of ethyl and methyl. That's why they have 1 ethyl, 3 methyl cyclohexanes. Please remember if they have similar, similar groups, you have mentioned 2 numbers. For example, if you have another methyl groups here, you have to 1, 1 diethyl, for example, like that. Okay. So naming alkene versus cycloalkanes. Okay, if the number carbon ring is greater, in the ring is greater, or equal to number of carbons, the longer it is of the compound named as cycloalkanes. If there are more carbon in the change, the compound name is alkanes. This is a very simple examples. For examples here, so if the carbons, for example, this one C6 and C4, we are prefer to use this one as a cyclo compound as the parent name. Okay, and if we have, for example, lowest number for the cyclic ring, okay, for example, this one is C4 and this one is C6, we are using this one as the parent name. Okay. Example of naming of cycloalkane, for example, this one is as ethyl-cyclobutanes. Why they call ethyl-cyclobutane? Because this one is C4, this one is C2, this one is become parent name. Okay. Similar with another ones, this is 1 secondary butyl, 3 methyl, 1 secondary methyl. Okay, because it's B. Okay, it's methyl, 1, 2, 3, 1 secondary butyl. This one is a secondary butyl. Okay, and this one is a methyl. Cyclohexane is 6-member ring. Okay, and this 1,2 dimethyl cyclohexanes, we can count clockwise or anti-clockwise, but we have to find the lowest numbers of the second substitutions. So it's become 1, 2, 3, 4, 5, and 6. So it's become 1, 2 because the substitution is similar. We should name dimethyl cyclohexane. Okay, this is similar goes by referring the what we have covered before. Okay, so you can easily name this compound as 1, 2, 4 triethyl cyclobutane. Okay. So common name for polycyclic molecules. Okay, some organic compound are identified using common names, which is not follow the IUPAC, because if they are follow IUPACs, the name is become longer. So yeah, for example, this one is cubine, housing is because the shape similar like house, Chechen is like church, okay, and basketing is like a basket. So many alkanes occur in nature primarily from natural gas and petroleum source, okay, and natural gas is composed largely of methane as a gas because the number of carbon is quite smaller, okay, with lesser amount of ethane, propane, and butane. Okay. So petroleum of complex mixture of compounds. More of the compound hydrocarbon contain 1 or 40 carbons. So, and they have we already learned from the crude petroleums. We doing fractional distillations, and we can get a gas, liquids. Okay, based on the number of carbons. Okay. And in refining of oil, distilling crude petroleums, co-refining process, okay, separate into usable fractionations that differ in boiling points. And for example, gasoline that we use in our petrol for the cars, and this for the lorries, kerosenes, okay, and so on. Okay. So I have experience working with Shell before I'm joined I'm doing master, so it's a good experience. If you have opportunity to work with a petroleum company, go for it. Okay, it's a good experience. I spent there around 3 months, and after that I resigned because I want to do master. So okay. And for the properties of alkenes, okay, as we know in chapter 3, they have only C and CH bonds. They only exhibits weak van der Waals force or London force, okay, which is affect the solubility and boiling point, including melting point, which is covered the characteristic of alkenes. Okay, solubility of alkenes, it's soluble in organic solvents, okay, insoluble in water because they doesn't have any capability to make a hydrogen bonding with water. So this is the physical properties of alkene. It's already summarized in these tables. I already give my lecture notes there, so it's easily to understand about these ones, okay? Including the boiling point and melting point, increase the number of carbons, okay? If the boiling point decrease with the branchings, because it will decrease the surface area. Everything in chapter 3. That's why I ask everybody don't left every chapters, okay, because it's already related, okay. For the solubility, it's already soluble in organic solvents, not in water. Okay, for the conformations of acyclic alkenes, okay, conformations are different arrangement of atoms that interconverted by rotation of single bonds. Okay, conformations, where is my pen? Conformations are different arrangement of atoms that interconverted. Okay, the compound is not stay like that. Okay, it's not stay like that. It's already moving. Okay, if they give you more energies, it will move very fast. Okay, and sometimes it can break the bond. Okay. Okay, so it can easily rotate because it doesn't have any pi bonds. Okay, okay, easily to rotate here. Okay, and in this case they have two different conformations. Okay, the first one, they have two different conformations. The first one is eclipse. Okay, the CH bond is aligned. This one is aligned with this one, and this one is aligned to this one. Okay, it's become this like this. I'm not sure you can see this one. It's aligned. Okay, this is aligned like this. Okay. Okay, so if we rotate 60 degrees, okay, if we rotate, it's aligned like this. If we rotate 60 degrees, it's become like this. It's become like this. Okay, so this one is become staggered. Bisect. Okay, bisect between. Okay, it's become this. Okay. So you have to remember this one, eclipse and also staggered conformations. So rotating one carbons to 60 degrees, okay, convert an eclipse to staggered, okay, and vice versa. Okay, if you rotate from eclipse to 60 degrees, you will change your staggered. If we rotate another 60 degrees, it's become eclipse again. Okay. The angle that separate the bond on one atom from a bond to adjacent we call dihedral angles. Okay, this is dihedral angles is around. This one is 60 degrees. That's why when we try to convert from eclipse and we rotate around 60 degrees, it's become staggered, and this angle we call dihedral angles. So, okay, boom. Okay, in this subchapters, we will study about the Newman projections. Okay, Newman projections, and how we can it's a representation of conformations between eclipse and staggered. And how to draw the Newman projections. So first, for example, so let me okay, this one. Okay, we can have this model kits. So look direct down the CC bond and on and draw the circle dot. Circle dots is at the front. Okay, circle dot is at the front, and the big circle at the back. So which is represent like this. So and after that, draw the bond. Okay, if there are this one. Okay, so draw the bond. We take a staggered. Okay. If there are in staggered conformations, we have to do like this. Okay, if there are, what you can see clearly is the front bonds. Okay, the front which is here. So Y. Okay, and the back is Y terbalik. Okay. So draw the bond at the back as a 3 line coming out the edge of circles. Okay, this is the back. This is from the front. You can see clearly here, and this one is at the back. Okay. So add the atom of each bond. For example, this one is ethyls. Okay, they have 2 carbons here, so you can easily put all. This one is hydrogens. If they have the branch, okay, I remove this one. I put this one. Yeah. Okay, the branch like this. This compound, this group is branch. Okay, you have to draw it. Okay, by using skeleton structure, not the condensed or Lewis structures. Okay, change it back. Okay, so this is the staggered conformations. Okay, like stars. Okay, with the 6. Okay, so if we change to 60 degrees from staggered to eclipse, you have freedoms to rotate the front bond and the back bond. So I prefer to rotate at the back, maintain the fronts. So it's become like this. Okay, so it's become eclipse conformations. Okay, so staggered and eclipse conformations of ethane interconverted at room temperature, it means it's moving around. Okay, it's easily to move. Okay, because it's not stay at the one positions. So the staggered conformations are more stables. Okay, the staggered conformations with the 6. Okay, staggered conformation like this. Okay, like this is more stable because they have a lower energy compared to eclipse conformations, because eclipse conformations, they have some kind of interaction, which is we will cover after this one. Because this one is for the staggered conformations, the interaction is quite far. Okay, doesn't have any interaction or repulsions between electron cloud here. For the proton, it's okay because electron cloud is shape is spherical. But the problem, if they have a substitutions with the huge functional groups, it could be different. Okay, so that's why in Newman projections, we are preferred to draw all the Newman projection in staggered conformations. Okay. Okay, as a statement here, electron repulsions, electron repulsions between bond in eclipse. Okay, conformation increase the energy compared with the staggered conformation where the bonding electrons are further apart. Okay, for example, if we like this, okay, this is the eclipse conformations. They have electron cloud here, so they have some repulsions compared if we draw like this. Okay, if we draw like this one is Y, this one electron, the functional group at the back doesn't have any interaction with the neighboring function, neighboring neighboring substitution here. For example, this methyl doesn't have any interactions. Doesn't have any interactions. There are low in interactions between these two proton here. Okay, compared to this one. Okay, they have 3 interactions. Okay, torsional energy of ethane. The difference between in energy from staggered and eclipse conformations is around 3 kilocalvin per mole. So it's not much, but it still have the difference of energies. Okay, because we already discussed in electronic levels. Okay. Okay, the energy difference between staggered and eclipse conformer we call torsional energies. Okay, so torsional strain is increasing caused by eclipse interactions. Okay, if they are in eclipse, okay, like this, they have torsional strain. So for Newman projection for propanes, we have 1, 2, 3 carbons. Okay, this is propane. Okay, this is propanes. And okay, if we draw like this, okay, it's become like this. So if we draw staggered, okay, we have CH3 on the top here. Okay, CH3 on the top. We have CH3 on the top, okay, which is here at the back. So we have Y shape for the methyl here. This one, 2 and 3. We have another CH3 at the back. Okay. Okay, we have CH3 at the back. Okay, so they have another 2 CH3 here. CH2. So, okay, this is staggered conformations, which is preferred because the CH3 doesn't have any interaction with another atoms. Okay, so if we draw eclipse, okay, I prefer to change to rotate at the front in this time. So I rotate here. Okay, it's become like this. It's become like this. Okay, so we have 2 CH3 at the back, and hydrogens. We have another CH, and CH. But the problem is they have interactions between torsional strain between CH3 and proton. Okay, so this if we rotate from 0 degrees, this we can assume as a 0 degrees, and we rotate 60 degrees. Okay, eclipse is become staggered, it become eclipse, it becomes staggered until 360 degrees, going back to original structures. Okay, it can be represented by this drawing. Okay, what I can see. Okay, and it will give 6 different conformations. Okay, but okay, it's better to start with energy minimum, which is the most stable one. This one is butane. Okay, the most stable one. It means you have to draw the most stable one. It's easy because it will reflect the energy diagrams. So for example, we have butane. How to draw it? Oh my God. No. I think butane we can continue later. Okay, make sure you understand about propane first, because I don't bring back my model. I have to find my model at my office first. So it's not enough. The bond is not similar length. So I think that's all for today. For today, we will already covered the first one, how to name the linear and the non-cyclic alkanes, and after that followed by cyclic alkanes. So the second one, we already explained about the physical properties about the alkenes, and lastly, like this one, we already covered the Newman projection, which is very important. We stop at the cyclobutane. Let me find my model at my office first. So we will continue later. Okay. So we have we cover until chapter number 42. I guess on this Wednesday we can finish, and Thursday we can proceed with the question and discussions. Okay, I think that's all for today. Thank you very much. Hopefully you already sign in your attendance and make the exercise. Okay, thank you. See you. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Yes, come on, shorty, let's go. Girl, I see you over there in the corner of the dance floor, and I know you're acting shy, looking at the corner of your eyes. So I pick my heart up off the floor, move my feet closer to yours, catch my breath and I say, I'm the one you're looking for. So come on, dance a little dance, take my hand, darling, take a chance. You be my queen, I'll be your king, show you everything that you've been missing, shorty. So come on, dance a little dance, got me in a trance in just one glance. So don't wait no more, I'm me, I'm more, I'm the one you're looking for, shorty. Girl, I see you over there hesitating, deliberating, you keep me waiting on a sign, looking at the corner of your eyes. So I pick my feet up off the floor, move my hips closer to yours, catch my breath and I say, I'm the one you're looking for. So come on, dance a little dance, take my hand, darling, take a chance. You be my queen, I'll be your king, show you everything that you've been missing, shorty. So come on, dance a little dance, got me in a trance in just one glance. So don't wait no more, I'm me, I'm more, I'm the one you're looking for, shorty. I'll be the one you're looking for, shorty. So come on the dance floor and baby show me all your moves, all your grooves, shorty. I got something to prove to you. So come on, take a little chance, got me in a trance in just one glance. So don't wait no more, I'm me, I'm more, I'm the one you're looking for, shorty. So come on, dance a little dance, dance a little dance. Come on, dance a little dance. So come on, dance a little dance, take my hand, darling, take a chance. You be my queen, I'll be your king, show you everything that you've been missing, shorty. So come on, dance a little dance, got me in a trance in just one glance. So